Hi, welcome back to the channel. In this lesson, we will see Hooke's law. I will explain the concept of Hooke's law and use the graph of load against extension to explain the concept of elastic limit and yield limit. At the end, I will use an example to show you how to solve questions relating to Hooke's law. That said, Hooke's law states that the force F required to stretch this string is directly proportional to the distance x via which this string is stretched, provided its elastic limit is not exceeded. Now, this force F, Hooke's law says this force F is directly proportional to x, while some textbook will put it x as what? As E. Don't get confused. All they refer to is the distance through which the spring is stretched. So, to now introduce the constant of proportionality, we'll say that F is equals to Ke, where K is the same thing as F over E. So, while F is force, is measured in newtons, E is distance, is measured in meters, and K is a constant of proportionality, and from here, it's obvious that K will be measured in newtons per meters. Now, this force, let's use the load and extension, let's use the load against extension graph to understand. Here I have my force, and here I have my E, that's the extension. Hooke's law, that's the extension. Hooke's law states that the force applied to this spring is directly proportional to the extension E until its elastic limit is exceeded. Now, let's label this point as my point P. Until this point P, Hooke's law is obeyed and extension is proportional to the force applied. My point P is also known as the proportionality limit. I can call my point P here my proportionality limit. Now, after this point P, up to a little point above it, then I call this point my elastic limit. Let me call this point E. Now, the point E is my elastic limit. Nonetheless, up to the point E, which is my elastic limit, the object will still return to its original position. After the point E, the material continues to stretch and does not obey Hooke's law any longer and enters what we call the yield point. Let's label this point Y, where it enters. I refer to it as the what? The yield point. At the yield point, the material is said to be yielded, and it has lost its elasticity permanently. At this point, the material begins to behave like a normal plastic. So, for a material to actually obey Hooke's law, the material must not exceed its elastic limit. Let's see an example to illustrate this better. Our example says that a force of 2 Newton stretches an elastic material by 30 millimeters. What additional force would stretch the material by 35 millimeters? Assume that the elastic limit is not exceeded. Since we are told that the elastic limit is not exceeded, that is, Hooke's law is obeyed. So that I can conveniently say that our F is proportional to E. That implies that our F is equals to Ke. Now, so if F is actually equals to Ke from this question, conveniently, I can say that my K is equals to F over E. Now, there are two instances here. The force of 2 Newton stretches an elastic material by 30 mm. I prefer to call that F1 is equals to 2 Newton, and the second, and its extension E1 is equals to 30 mm. Now, what additional force, the force that will be required, F2, to be equals to, is unknown, to stretch the material by 35 mm. So that my F1 all over E1 will be equals to F2 all over E2, and they're both equals to K. So that F1 now in this case is 2 over 30 is the same thing as F2 over E. E in this case is 35. Now, this implies that 2 times 35 over 30 is equals to F2. Now, if you observe, in this question, my distances are given in mm, in millimeter. Both of them are given in millimeter. That is why I did not convert to the SI unit, which is meters. And I know for sure that they will cancel out. Even if you tend to convert, you'll be converting this by 1000, this by 1000, they will still cancel out. That's why I left it like that. So from here, 5 in 30, that's 6. 5 in 35, that's 7. 2 here is 3. 2 here is 1. So my my F2 is the same thing as 7 over 3, which is equal to 2 whole number 1 over 3. That's the same thing as 2.33 in newtons. So the question is asking me of the additional force. The additional force will definitely come from F2 minus F1, which is equal to that's additional force. That's an increase in the force. So that F2 minus F1, that will be 2.33 minus 2 Newton, which is the same thing as 0.33 Newton. So my additional force that is required is 0.33 Newtons. With this, I hope you understand how to solve questions relating to Hooke's law. In our next lesson, we'll take further questions to illustrate it. Thank you and see you in our next class.